Problem A3. A ship can be thought of as a symmetric arrangement of soft iron. In the presence of an external magnetic field, the soft iron will become magnetized, creating a second, weaker magnetic field. We want to examine the effect of a ship's field on the ship's compass, which will be located in the middle of the ship. Let the strength of the Earth's magnetic field near the ship be BE, and the orientation of the field be horizontal, pointing directly toward true north. The Earth's magnetic field BE will magnetize the ship, which will then create a second magnetic field BS in the vicinity of the ship's compass given by this formula, where KB and KS are positive constants. Theta is the angle between the heading of the ship and the magnetic north, measured clockwise. Ports B and S are unit vectors pointing in toward the direction of the ship, bow and directly right of the forward direction, starboard respectively. Because of the ship's magnetic field, the ship's compass will no longer necessarily point north. Question A. Derive an expression for the deviation of the compass delta theta from north as a function of KB, KS and theta. Question B. Assuming that KB and KS are both much smaller than 1, at what headings theta will the deviation delta theta be largest? A pair of iron balls placed in the same horizontal plane as a compass but a distance d away can be used to help correct for the error caused by the induced magnetism of the ship. Just like the ship, the iron balls will become magnetic because of the Earth's field BE. As spheres, the balls will individually act like dipoles. A dipole can be thought of as the field produced by two magnetic monopoles of a strength plus minus m at two different points. The magnetic field of a single pole is B equal plus minus m multiplied by vector r divided by r square, where the positive sign is for a north pole and the negative for a south pole. The dipole magnetic field is the sum of the two fields, a north pole at y equal positive a over 2 and the south pole at y equal negative a over 2, where the y-axis is horizontal and pointing north. A is a small distance, much smaller than the radius of the iron balls. In general, A equal Ki multiplied by BE, where Ki is a constant that depends on the size of the iron sphere. On the picture, a binnacle protecting the ship's compass in the center with the two soft iron spheres to help correct for errors in the compass heading. The use of the spheres was suggested by Lord Kelvin. Questions. Question C. Derive an expression for the magnetic field BI from the iron a distance d much greater than a from the center of the ball. Note that there will be a component directed radially away from the ball and the component directed tangent to a circle of radius d around the ball, so using polar coordinates is recommended. Question D. If placed directly to the right and left of the ship compass, the iron balls can be located at a distance d to cancel out the error in the magnetic heading for any angles where delta theta is largest. Assuming that this is done, find the resulting expression for the combined deviation delta theta due to the ship and the balls for the magnetic heading for all angles theta.